Okay, everyone, let's talk about the scientific revolution. It is a key event that occurs during this time period. We've been talking about some political issues going on, the rise of absolutism, for instance, development of constitutionalism, a constitutional monarchy. Now we're going to look at sort of scientific and intellectual developments that occur in Europe and pretty much make Europe one of the dominant regions in the world because it is going to be a continent that embraces this new science, the new technology, and some of the reforms that come out of the Enlightenment, the Age of Reason that we talk about. So it's a very, very important movement. Obviously, today we live in an age where science and technology are highly, highly respected and valued and very important in our lives. They increase our lifespan, make lives a lot easier. We're using technology for this class, for instance. So it's a very, very important part of the European and Western heritage. So let's look at what's going on, because the first part we're going to talk about with regarding scientific advances or advancements, I should say, occur in the realm of astronomy. Basically, our solar system, the world we look at when we look at the stars and the world of the planets and all of that stuff. And what the scientific revolution is going to do is revolutionize the way at least educated people think about the universe around them and the role of humanity within that sort of new system that emerges. For the most part, what you have is the idea about a universe up until the scientific revolution that for the most part, the Earth is at the center of the universe. It sits motionless at the center of the universe. And all the sun and the planets revolve around the Earth. This is an idea that goes all the way back to ancient philosophers and scientists like Ptolemy and Aristotle, who support this notion of an Earth-centered universe. And it kind of fits neatly with Christian ideas as well. You know, if humanity is the ultimate creation of God, where would God put humanity? Well, it would be at the earth, at the center of his universe. And there's also some passages in the Bible which indicate that the earth is motionless at the center of the world. So it kind of fits neatly with Christian principles. The church adopts this. Both Protestant and Catholic churches accept this. They think that the Bible supports this view, and they rely on individuals from the ancient world, respected scholars like Ptolemy and Aristotle. But you see, I have a couple of names up here that look at that are going to revolutionize and change the way we see the world around us and point to a sun-centered universe. It's going to start with a Polish clergyman, Nicholas Copernicus, a Dane, Tycho Brahe, a German, one of his assistants, Johannes Kepler, an Italian, Galileo Galilei, and an Englishman, Isaac Newton. And those are only a few who were involved in this. So you can see you've got a Pole, a Dane, a German, an Italian, and an Englishman. And what you're seeing is that these scientific advancements are occurring throughout Europe. It's not just one country, one region doing this, but they're occurring throughout Europe. And here you have this old Earth-centered universe, this conception of an Earth-centered universe. Here's the Earth, the moon, and everything else revolves around the earth. And it's a very, very complicated system. It doesn't lead to the most accurate of predictions. And that's going to cause some thinkers to look and think about this in different ways. Here's another example of that. And as I mentioned earlier, you know, the whole notion of Christian churches accepting this. You know, you can look at passages like in Joshua, where Joshua commanded that the sun stand still. So, you know, why would Joshua say that if the sun were moving? He wouldn't have to say that. And just think about the way we view the world around us. If we wake up in the morning, where's the sun? Where is the sun at noon? Where is the sun just before the end of daylight? So people can look at this and say, well, the sun is moving. It's over here and it sets over here. So you can see what kind of crazy person would not think that the sun is moving around the earth. And if the earth moves, why aren't we falling down? So you can see people weren't exactly irrational in the way they understood the earth-centered universe. It's something that lasted for centuries, this idea. It lasted for centuries, the acceptance of an earth-centered universe. And that's what makes it a challenge. And that's also why science sometimes is very challenging for people who are deeply religious. Not all religions, but some people who are deeply religious, where science may point to a scientific truth which may differ from the religious beliefs that some people have. So it's a very much a challenging situation. But here you can see Nicholas Copernicus. Look at that awesome hair that dude has. He's a Polish clergyman. And that's something you need to remember about all of these people. They are deeply religious. And what they think they're doing, even though they challenge traditional church teachings on the nature of the universe, they think they are understanding God's creation in a better and more accurate way. They're not atheists. Atheism is more of a modern idea. So they think they're just coming up with a better understanding of what God created, why he created, and how God's creation operates. So think about these people. They are deeply religious. And it's Copernicus who is a mathematician. He uses math to develop this new system of a sun-centered universe with the Earth and the planets revolving around the sun. So he works it out mathematically. So he's very well educated. He waits until the last year of his life before he publishes this. You can get in a bit of trouble if you challenge traditional church teachings on this. We'll see if that happens to Galileo. So that's one of the reasons why he waits, but he also spends time making sure that he's as accurate as he can be. So he develops this idea and it spreads like wildfire. Remember, this is a time when we have a printing press, we have an educated population, they are just gobbling it up, and it makes sense to a lot of educated people. Johannes Kepler, he was the assistant of that Dane, the Dane Tycho Brahe was a guy who built his own observatory and gathered enormous amounts of data. Johannes Kepler looks at some of this data and decides to develop or comes up with this idea of his 3 laws of planetary motion. Copernicus believed that the movement of the planets around the sun was in a perfect circle. Kepler says, no, it's elliptical, along with a couple of other laws. So you can see Copernicus thinks he's right about some things, but this is what science does. It challenges itself through testing and observation and replication to make sure that it works. So here's Brahe with his observatory. Kepler, who reworks the Copernican system, includes new laws. And then there's Galileo, an Italian from Florence, who works out his law of inertia, builds his own telescope, starts looking at the universe, sees craters on the moon and all of that. And he said, and the idea is that away from Earth, you get closer to heaven, so heavenly bodies are closer to perfection. Well, why does the Earth have craters, for instance, and all this other stuff? Why are there other moons out there? That sort of thing. So he's writing about all kinds of interesting things, and he is an advocate of the Copernican theory, that he is an advocate of a sun-centered universe. And for him, he believes in what we would basically consider to be a scientific method. If you want to understand the world around you, use your sense experiences and examine the physical evidence and test it and reach conclusions, develop theories and reach conclusions and test those theories. Test them mathematically. Math is the science of, or math is the language of the scientific revolution, and is still obviously important today. There's Galileo. The interesting thing about Galileo, though, he is in Italy and close to the Pope. Italy is dominated by the Catholic Church, and Galileo is going to be put on trial for heresy before the Inquisition. He's going to be accused of being a heretic, and he's going to have to recant his belief in Copernican theory. Although supposedly he whispers to himself, he wants to stay alive, obviously. Supposedly he whispers to himself, but it moves, that the Earth actually moves. Another key figure with awesome hair, by the way, is Isaac Newton. This is an Englishman. And the key thing about Isaac Newton is his development of calculus and his use of mathematics to sort of tie the system together, tie movement in our solar system, the movement of planets, and movement on Earth in a new idea called universal gravitation, which we refer to the law of universal gravitation today, or gravity. He says gravity explains motion throughout the universe. Can you see it? No, but he knows it's there. He works it out mathematically. And that's the key here when you look at some of this. And these are some of the things about Galileo. Newton himself was religious. It's a big, big challenge to religious teachings at this time. And look at what Galileo says about the Bible. Galileo believes in the truth of the Bible. What Galileo is essentially saying is that perhaps the way we interpret the Bible today, or at that time, is mistaken. Maybe we're not interpreting it properly. Maybe the words of the Bible don't mean exactly what we think those words mean. Maybe there are hidden meanings that lead us to a greater truth. And I want you to read about some of these things and how he defends his views of gathering information and using his sense experiences. It's obviously a huge, huge challenge for religious leaders at that time. Cardinal Bellarmine is a deeply, deeply educated mathematician within the church. He's a cardinal. And he says, if you want to believe that this new system is real, that the sun is really the center of the universe, then that's a very dangerous thing. What else are you going to believe about the Bible? What about those passages that call for an earth-centered universe? Can you just make up anything you want about what the Bible means? And so it's a very dangerous thing. But later on, Bellarmine comes to the conclusion, he is an educated man, and he basically says that if there is a demonstration, if you can prove it, that the sun is the center of the universe, then we're going to have to be very careful about reinterpreting some of these passages in the Bible. They will have to be reinterpreted. And we'll have to explain carefully why earlier religious leaders perhaps misinterpreted them. What's important here with this new science is governments get involved, explorers get involved, and they start gathering more and more evidence around them. Looking at the New World, what did people in the New World use to sort of treat diseases? What sort of science did they have? So the Spanish are very, very important in gathering all kinds of information and contributing to these fields like botany and zoology later on, including one of this individual, Francisco Hernandez, his personal physician. Look at that, 15 volumes illustrating the different types of plants, thousands of plants and things that are gathered from the New World. And all of this is going to get cataloged and re-examined and looked in new ways. I mean, the cataloging, thinking about how living things are cataloged today. Carl Linnaeus is important in that. Francis Bacon, who's a key figure in this. He's a philosopher who promotes this whole notion of a scientific method. He gets the English king to create something known as the Royal Society, a society committed to promoting science, advancing science, and using science to improve life within England and elsewhere. So you begin to see governments getting involved in promoting the use of science. Remember, most people are largely illiterate peasants. They're uninvolved in a lot of this stuff, but we'll see that it ultimately affects them. But Francis Bacon promoting this idea of the importance of empirical observation. If you want to learn about something, don't just think about it and speculate, study it, develop a theory, test it, use math. That's very, very important in science. And you can see these are some of the others. The Dutch are involved by this time. You can see how some medical advancements come because of dissection. That is, scientific advancements do challenge some prevailing religious taboos against doing and studying certain things. So for medical training, how do you find out about the body? Well, dissection is going to be very, very important. William Harvey, an Englishman as well, William Harvey, circulation of the blood. Edmund Halley, by the way, we have a comic named after Edmund Halley. So this new science, it really, really is a revolution. And revolution involves incredible change, a change that occurs, a revolution. We're going to talk about the American Revolution. We talked about the English Revolution, where you had a change in government. This is a change in the way we look at the world around us. And we rely on science today in so many areas of our own lives. But this idea, human beings are endowed with an intelligence that they can discover nature and understand nature's secrets and understand more about nature than prior human beings. That's what this scientific revolution sort of inculcates in a number of people, that we can discover more about nature than anybody else in previous generations. Many of them are deeply religious, so what they believe they're doing is understanding God's creation. So they're not atheists. And it gets men to think about all kinds of different possibilities. If we can understand how the planets revolve around the sun, maybe we can understand how disease works. Maybe we can do a number of things to make life better for people, increase the food supply, irrigation system or dams or divert bodies of water, all kinds of things to improve someone's life. I mean, again, think about how science benefits us today. And there is this idea, there is this challenge. If people understand how the world works using science, that is through non-religious means, then they're going to be less religious. It doesn't actually work that way initially. Most of these scientists are very much religious in nature, and even today you have religious people who are who very much respect the scientific method and all of the wonders that science teaches us.